Okay, these sections are about quadratic functions, how to graph quadratic functions which make parabolas. So you have to know these basic concepts from the sections. Okay, one is you need to make sure that you know how to comfortably find the vertex from either standard form or vertex form. So to find the vertex from standard form, you need to use a formula to get the x-coordinate opposite b over 2a. So in this case, a would be 4 and b would be negative 4. So what you're going to do is you're going to plug in b and a into this formula, and then once you get what this number is, this is your x value, so you're going to plug in x in to get your y value. So I'm going to do that right now. So when I do an opposite b over 2a, I get positive 4 over 2 times 4, which is 1/2. So this is my x-coordinate. To get the y-coordinate, I'm going to plug in x, or evaluate x as 1/2, and see what I get for y. So it's going to be y equals 4 times 1/2 squared minus 4 times 1/2 plus 2. So first I do order of operations. I'm going to do 1/2 squared, which is 1/4. So 1/4 times 4 is 1. So this is 1 minus half of 4 is 2 plus 2. So 1 minus 2 is negative 1 plus 2 is 1. So my vertex is at 1/2, 1. You should also feel comfortable finding the vertex from vertex form. So vertex form is y equals a times x minus h squared plus k, where your vertex is hk. So in this case, since this is x plus 2 and this is opposite h, the h value, or the vertex value, is going to be negative 2 for the x, and the y is going to stay at negative 6. So over here you can see what the vertex is in a parabola. It's either, you can also call it the minimum or the lowest point. And you can also see that the vertex, the vertical line that goes through it, is the equation for the axis of symmetry. It's always going to be x equals a number. And in this parabola, it crosses the x-axis twice, but sometimes it crosses once, sometimes it might not cross at all. And on the axis of symmetry, it is a line of symmetry, such that every point on the parabola has an opposite counterpoint besides the vertex. So to find the axis of symmetry in standard form, remember it's just going to be x equals, and it's going to be whatever the coordinate is of the x-coordinate of the vertex. So in standard form, it's just x equals opposite b over 2a. And if you remember vertex form, it's just going to be x equals h. It's going to be the x-coordinate of the vertex, which is h, in vertex form. Just make sure that you write an equation. So it's a vertical line, so that's why it's x equals. Don't just give a number. Now, a y-intercept of a parabola is where, just like any function, the function crosses the y-axis. So when the function crosses the y-axis, the x value is 0. So all you need to do to find the y-intercept is let x equal 0 and find your function y, or f of x, whatever notation you are using. So in standard form, actually, it's always the c value. So the y-intercept is 0, 2 in this case. But in vertex form, you're going to evaluate x equals 0, plug in 0 for x, so you get 4 minus 6. 4 times 4 minus 6 is 16 minus 6 is 10. So the y-intercept for this function is 0, 10. A common mistake is to write that the y-intercept is negative 6. This is not true. This is the y-coordinate in vertex form of the vertex, which is not the y-intercept. You should also be comfortable with graphing a parabola, both in standard form and in vertex form. So either way, what I do for both is I find the vertex. So I'm going to find the vertex. So I found the vertex by doing opposite b over 2a, and I get -1. And then I plug -1 back in here very carefully, making sure I'm using parentheses because -1 squared is +1. After I do this, I put the vertex in the center of my table. So -1, -3. Now I can either put in two other points on the left and right hand side of my point -1, 0, or -1, -3. So I would do 0, -2. A faster way that I like to graph a parabola is in standard form is I like to look at the vertex or at the y-intercept being -1 and understanding that the vertical line that goes through the vertex of the parabola is the axis of symmetry. This is a line of symmetry. So that means that this other red point is directly across and equidistant, making a perpendicular line with the line of symmetry. So I have 2 points here. So if I plugged in -2, I would get -1, and if I plugged in 0, I would get -1. It's symmetrical on my table, and it's symmetrical in my graph. And I can also find graph from vertex form by finding the vertex. So the vertex is going to be opposite or -1, +3. So I go -1, +3, make a dot. And I could pick values again. So -2, 0, and I can plug in 0 for x. So I'd get -2 times 1 squared plus 3. So -2 plus 3 is 1. So both of these are 1, 1. And you can always pick more. You can always pick more points. I would encourage picking more than just 3 points, maybe having 5 points. You should be able to write a quadratic equation from a set of data both by hand, algebraically, by writing a system of 3 equations, and on your graphing calculator. So if I do it by hand, what I'm going to do is I'm going to take an x and a y 3 times and plug it into our standard form of a quadratic, y equals ax squared plus bx plus c. So if you remember a line, you need 2 points to draw or to write an equation of a line. You need 3 points to write an equation of a quadratic. So I'm going to plug these in and then stop. So I simplified each one of these lines. So this equation became this equation simplified to this equation simplified to this. Just be careful when you're plugging in a negative and you're squaring it that you make sure it's positive. So now I'm solving a system of 3 equations. So what I'm going to do is I'm going to use substitution and I'm going to plug in c is 0. Now I have this system of 2 equations where I need to solve for either a or b. So I think what I'm going to do is I'm going to multiply the bottom line by 2. That's going to get my b's to cancel out. So I'm going to multiply the bottom by 2 and get 24 equals 2a plus 2b. So now I can use elimination and add these 2 equations together. These 2 will cancel out, and I'll have 6a, because 4 a's and 2 a's is 6 a's, equal 18 plus 24 is 42. So I'll have 6 a's equals 42, so a has to be 7. I already have c equals 0. I can plug a, c in for here to get b equals 5. So my quadratic, if I use a is 7, c is 0, and b is 5, it's going to be y equals 7x squared plus 5x. And you can check by making sure that each of these x and y's satisfy this function right here. On a graphing calculator, what you're going to do is you're going to put in these points for your L1 and L2. Then you're going to want to go to Stat, Calc, and you're going to want to choose the quadratic regression. So Stat, Calc, hit the quadratic regression. And it'll give you your A value, your B value, and your C value. You should also be able to convert from one form to the other form. So to go from vertex to standard form is ax squared plus bx plus c. So you want to remove the parentheses. So I'm going to distribute x plus 2 times x plus 2. I'm going to write it twice, plus 5. So multiplication is commutative, so you can either multiply these two and then multiply it by x plus 2, or you can multiply these two binomials and multiply it by negative 3. I'm going to multiply negative 3 times x plus 2, so it's negative 3x minus 6, and then I'm going to multiply it with x plus 2. So it's going to be negative 3x squared minus 6x minus 6x minus 12, and then I have this plus 5. So if I clean that up, combine like terms, write it from highest to lowest degree, I have y equals negative 3x squared minus 12x minus 7. To write from standard to vertex form, you need to find the vertex. So I'm going to find the vertex. So I found the vertex, 1, negative 13. So this is my h, this is my k, and I already have my a right here. My a is the coefficient of x squared. So I write y equals a, which is 3, times x minus h, so it's x minus 1 squared, don't forget the squared, and then minus 13 because that's my k.